Hey, you, my lovely students, welcome to Students' World. Today's topic is periodic classification of elements. So, in your book, you have three types. One is Dobereiner's triad, then the other one is Newland's law of octaves, and the other one is Mendeleev's periodic table. So, let's see Dobereiner's triad. Before explaining this, let me just give you a background. Like when the elements were found, they were not having the chemical properties or the physical properties did not know. They were just simple elements like hydrogen, oxygen without a name. So there was a person named Dobereiner. He, in his late 18th century, what he did was he thought of classifying these elements. So let's see the law first, which he made. So, according to Dobereiner's law, when elements are arranged in an increasing order of their atomic masses, the atomic mass of the middle element is approximately to the mean of the atomic mass of the other two elements, which means that Dobereiner, what he did was, he classified the elements based on their atomic mass. This is very important. And then what he did was the middle element he took and took the mean of the other two elements. Let us see this with the following example. So I have taken alkalite group metals which contains lithium Li, which contains sodium Na, and which contains potassium K. So let's see how he classified these and made Dobereiner's law. So I told you in the start that he did increasing order of their atomic masses. So atomic mass of lithium is 7, atomic mass of sodium is 23, and the atomic mass of K, which is potassium, is 39. So what he did was, according to the law, he took the mean of the first and the third element, and the mean will give you the answer of the middle term. So let's see the formula. Arithmetic mean is equal to first element plus third element divided by 2. Means in this case 7 plus 39 divided by 2, which will give you 23, which is the atomic mass of sodium. So for everything there is pros and cons. Similarly, there are some limitations of Dobereiner's triad. Let's see it. First, he failed to arrange all the known elements in the form of triads. Means he could only identify 3 triads, which is of one is lithium, sodium and potassium, then the halogens, and then calcium, strontium and barium. These are the only 3 triads of the known elements he could classify. The next one, like each and every product has its new version. Like you have iPhone 13, then comes 14, isn't it? So here, after Dobereiner's triad failed, there came up a scientist named as Newlands. So let's see his law. The law of octet. It states that every 8th element has similar properties when the elements are arranged in the increasing order of the atomic masses. So he continued with the increasing order of the atomic masses given by Dobereiner, but he said his notice that every first element is similar to the 8th one. So let's see some examples of it. Let's consider this element. Lithium 1, 2, 3, 4, 5, 6, 7 and the 8th element. Means lithium has similar properties to Na, sodium. Similarly, beryllium with magnesium, boron with aluminium, carbon with silicon, and so on. So let's see the limitations of Newland's law of octets. First, several elements were fit in the same slot in Newland's periodic classification. For example, I'll take cobalt and nickel. So they were placed in the same place. Then elements with dissimilar properties were grouped together. For example, halogens were grouped with some metals. Means two different property elements were placed in the same place. Then the elements were discovered in the later could not be fit in the octave pattern. So there were some elements which were found out after Newland's law of octaves. So those elements were not being able to fit in the table. And Newland's law of octaves held truth only for elements up to calcium. The metals or the elements after calcium could not be fit in the Newland's law of octaves. So if you want, I would be creating a new video on Mendeleev's periodic table as well. If you like my channel, do subscribe, share and comment down below. Thank you.